Alright, section 2 video, we're going to talk about probability distributions. And what that is basically making a table or a histogram, or both, showing the probability distribution for a random variable. We're going to let x equal the number on a table tennis ball randomly chosen from a bag that contains 5 balls labeled 1, 3 balls labeled 2, and 2 balls labeled 3. So in order to find the probability of each one, we need to set up a table. So we could say that x equals the number of the balls chosen. So we have a ball labeled 1, a ball labeled 2, and a ball labeled 3. Kind of like the lottery. And the total amount of balls that we have altogether in this bag is, we have 5 plus 3 and plus 2, which would be 10. So what we could do is figure out if we have 5 balls out of 10 that are labeled 1, the probability of getting it would be a half. Or we could put the decimal as well, it doesn't matter. And then we have 3 balls labeled 2, so we have 3 out of 10 balls labeled 2, which is, reduced would be just 0.3. And again, you can put the fraction or the decimal. And then we have 2 balls labeled 3, so we have 2 out of 10 labeled 3, which would reduce to 1/5. And that would equal 0.2. So we have our table, and now we're just ready to set up the histogram. And so what we need to do is we need to label some axes over here. We're going to put probability on the side. And we're going to go all the way, it looks like we have from 0 to 0.5. So we can probably go by 0.1. So we have 0, 0.1, 0.2, 0.3, 0.4, and 0.5. And on the bottom we have the number of balls. And we only have a ball labeled number 1, 2, and 3. And it looks like if you draw a number 1 ball, the probability of doing that would be 0.5. So do the bar graph. And a probability of drawing a ball with a number 2 on it would be 0.3. And the probability of getting a ball with the number 3 on it is 0.2. And there's your histogram. Now there's also something called a binomial experiment. There's a few things that you need to know. It can be independent, meaning it relies on nothing. There's two outcomes, either failures or success. And the probability for each trial, which would be P, is the same. And the failure is 1 minus the probability. So we have this equation down here where we have the probability of K, which is also success, and we have the combination method that we were taught in section 1. We have the probability raised to the K, then we have the failure, which is 1 minus P raised to the total minus K. And so here are some examples I'm going to show you. We're going to calculate the probability of tossing a coin 20 times and getting the given number of heads. So if we toss a coin 20 times, we want to know what's the probability of getting 1 head. And we're just going to set up our equation. So we have n, that's the total number, so that'd be the 20 times. The k is the success, which is over here, we want 1 head. And the probability of tossing a coin is either you get it or you don't, so it's a 50-50 chance. So the probability would be 0.5. And then the failure, which is 1 minus P, is also 50, so it's a 50-50 chance. And so if we set the equation up, we have 20C1 times 0.5 raised to 1 times 0.5 raised to 19. Now remember, it's the n minus the k. So if there's 20 total minus what we want, that'd be 19. And when you plug this into your calculator, you get something like this. And I really don't want your answer in scientific notation, so you're going to have to move the decimal over 5 spots. Because it's negative, it's going to go this way. So you end up with this very small number. And that's the probability of getting ahead if you toss a coin 20 times. Now let's say we wanted it to be 6 heads. So we're going to do the same thing. The total number is still 20 times. And the amount of success would be 6. Now the probability is going to stay the same. It's 50-50 chance of getting a head or a tail. And the failure also stays the same because it's 50-50 chance. But this time it's 20 minus 6. And when you throw this in the calculator, you get 0.0369. Now we're going to calculate the probability of randomly guessing the given number of correct answers on a 30-question multiple choice exam that has letters A, B, C, and D for each question. So if I gave a 30-question multiple choice exam and you want to know the probability of only getting 2 of those correct, this is how you would do it. First we need our n, which is the total number of questions, and that is 30. And then we need the probability, and since we have 4 choices here, we are going to have probability of getting one of those right, which would be 1 out of 4, is 0.25. So the probability is 0.25. The failure, which is 1 minus p, is 0.75. And the success, which is our k, is 2. We want 2 correct answers. So we set up our equation. We have the total combination of 2 of those, and then we have the probability of getting them right raised to 2, and then the failure. And you have to remember, you have to take the total minus the success, which would be 28. And when you calculate this out, you should get 0.00863. And I'm just going to stop there. Now we're going to calculate the probability of k successes for a binomial experiment consistent of n trials with probability p of success on each trial. Okay, so the only difference here is that they don't give an equals 3 for k, they give a less than or equals 3. So in order to do this, we're going to do so we start at 3, we're going to take 3 from a total of 7. Now the probability is 0.3, and remember we want it to be raised to 3. The failure would be 1 minus 0.3, and that is 0.7, and that's going to be raised to 4, because 7 minus 3 is 4. And when you plug that in your calculator, you're going to get 0.0823543. Now that's at k equal 3. They want k equals 3 and less than that. So we now have to go to 2. We're going to write everything exactly the same, except for the 2 and 2 here change, and then 7 minus 2 is 5. And that becomes 0.3, sorry, this answer, I read it wrong, should be 0.2268945. Sorry, I apologize. And then the next one should be 0.3176523. Now we've got 3 and 2, now we go to 1. for this should be 0.2470629. And then last we have 0. And that answer was the 0.8082353. Okay, now that you have every single probability for taking, like success of 3, 2, 1, and 0, we want to add these up to get the total. So when you add all of these up, your total ends up being 0.874. And that is the probability of getting 3 successes or less. One thing you need to know about histograms is that they can be labeled 2 different ways. When your histogram looks pretty much the same mirror image on both sides and then one large one in the middle, it's very symmetric, and that's what they say, that all of the data is symmetric. Over here, if you notice, you can have all of the data kind of like put towards the left or the right of a graph. This one is put towards the left, and they call that skewed. So the graph for that would be skewed to the left. A binomial experiment consists of n trials with probability p of success on each trial. We're going to draw a histogram of the binomial distribution that shows the probability of exactly k successes. Describe the distribution as either symmetric or skewed, and then find the most likely number of successes. All right, so if we look at this problem, we have our n, which is 3, and our probability, which is 0.3. And so what we're going to do is we're going to make a histogram from 0 to 3. So let's start with 0. We're going to follow the formula that I gave you. Probability is 3. We want the k to be 0 for this one. Now 1 minus 0.3 is 0.7, and the failures would be 3. Down here, we're going to do k equals 1, and we're going to do the same thing. And then k equals 2. And k equals 3. And you want to calculate all these out into your calculator. And so you're going to get 0.343 for the first one, 0.441, 0.189, and 0.027. Now that you have all of your answers, we got to make your histogram. And again, it looks like the highest one is 0.3, so I'll make my graph go to 0.4. Or I'm sorry, the highest one is 0.4, it's a little above it. So we want to make the graph go to 0.5. So I'm going to extend this up a little bit here. And so we start with 0, 0.1, 0.2, 0.3, 0.4, 0.5. And you want to put a label, so this would be probability over here. I don't have much room to write it, but make sure you do. And then on the bottom we have successes. And we have 0, 1, 2, and 3. So when we have 0 successes, we have, which is k, k equals 0 is 0.343, so a little bit above. And then we have, for 1 success, is 0.441. And then for 2, we have 0.18. and for 3 we have 0.027. Okay, so you have your histogram now, and it says describe whether it's symmetric or skewed, and I would say that this one was definitely skewed to the left. And then it says find the most likely number of successes. Well, it would be this area right here. So the most likely would be 1.